Today we're talking two types of symmetry, line symmetry and rotational symmetry. So first is line symmetry, which deals with reflections. We think about if an object has a line that you could draw through it so that if you folded it or reflected itself, it would look the same on both sides. So maybe starting with this door would be smart. I would say that it has line symmetry right down the center, because if I folded it in half, it would look the same on both sides. Now that would be different if it had a doorknob already there, because then I probably wouldn't say that it has line symmetry unless it had two doorknobs. I don't think I would put this line in because you'll notice that it has a different pattern up on the top than it does on the bottom. So I'm going to say that the door just has one line of symmetry. This bagel or this donut or whatever it is has some line symmetry. If I folded that, it would be equal halves, looking the same on each side. But I could also split it sort of diagonally or horizontally, and it should look the same on both sides. In fact, I could really split it in half anyway. So how many different lines could I draw? I feel like I could draw infinitely many. And so this one actually has infinity lines of symmetry. For our starfish over here, it looks like I could fold them in half this way, looking the same on both sides. And actually, at each of those points, I should be able to do the same thing, right? So that's 1, 2. From here, I would have 3, 4, and 5. So that starfish will have 5 lines of symmetry. Now, a starfish also has rotational symmetry, which we're going to talk about next. So for rotational symmetry, we're actually picturing turning those shapes around to see if they would be like images of themselves. And you can see that this cross worked nicely for that. And I think this next one should work okay too, right? As we turn it, it has little pit stops where it matches up with itself. So that's rotational symmetry. And how about this last one? Rotational symmetry. So how far do I have to do it until it matches up with itself? I actually have to turn it all the way around. So we're actually not going to count that as rotational symmetry, because even the most awkward of shapes, if you turn it 360 degrees, it'll match up because it's back to its original position. So we don't say that that is rotational symmetry. So if it takes 360 degrees, we're going to say that that shape does not have rotational symmetry. Now these other two do, and how will we describe that rotational symmetry? We can't just draw the line like we did for line symmetry. So what we're going to do is we're going to figure out how many degrees it gets rotated before it matches up to its original sort of position. So how many degrees do you suppose one little turn would be on that first one? And the answer is 90 degrees. You can sort of picture this central angle as being a right angle in there. So that would be a 90-degree turn, and I guess I went clockwise first. But that's not the only one. I could have gone 2 clicks through. Did you see how I basically turned that upside down? So if I turn something upside down, that would be considered a 180-degree turn. And now to avoid having to list infinitely many angles, because I could just keep listing them as long as these were still matching up as I was turning, what we do is we don't go past 180. Once we get to 180, we stop and we take care of these sort of other 2 points with a counterclockwise rotation. Because I never did get that top side to go into that 1, 2, 3 third position over here. But then instead of going 1, 2, 3 90s to make it there, we're going to use the counterclockwise movement. So to match up with this side, I'm going to call that a 90 degrees counterclockwise rotation. And I suppose it's up to you if you mention this last one, because technically a 180 degree counterclockwise has the same effect as a 180 degrees clockwise. So whether you mention that one is probably optional. So the way that I would usually write my final answer is I would write 90 degrees clockwise and counterclockwise, and then 180 degrees. And I'm going to list both. It's a little bit redundant, but I listed both of them. So that's a nice description of the rotational symmetry of that red cross. You'll notice that this second shape actually has more rotational symmetry in a way, because there are more times that I can stop and have it match up perfectly. So I like to sort of pick a point and see when it's going to match up with a corresponding point. And then we'd want to figure out how many degrees is that. If we were looking at that central angle, how many degrees would this be? I'm pretty sure that's a 45-degree angle. But if you want to be sure, you could always take the complete rotation all the way around and divide it into how many sort of points there are on this shape. And I'm seeing that this has sort of 8 points where I'm going to be able to stop my rotation. So I'm going to take 360 divided by 8, and I do get 45 degrees. And so that just tells me that each of these little spaces from tip to tip here are going to be 45 degrees, which is going to help me describe the rotational symmetry. So I will list that 45-degree clockwise that I have drawn up there, but I'll also list the 45 counterclockwise at the same time. And then I could do a 45 plus 45, and that would work. And the counterclockwise version of that. So a 45 plus 45 makes a 90. Now down towards the bottom, that would take 1, 2, 3 turns of 45 degrees each, which is 135 degrees. Again, that should work clockwise and counterclockwise. And then the only one that I've missed is where you turn the shape totally upside down. 180 degrees, and I could do that either way. And so you might say that this shape has more rotational symmetry because it has more options. Let's try a few more just to make sure you got this. So we're looking again for rotational symmetry on these. We've got sort of a hubcap sort of thing. I'm going to follow that same strategy that I can see that if I turn that to here, or to here, or to here, then it will line up nicely, right? So if it has 7 points, I should be able to take that 360 and divide by 7, which doesn't actually come out to a whole number. It's about 51.4 degrees. So that would represent these top 2 turns, 51.4 degrees clockwise and counterclockwise. But then I could do 2 of those 51.4s. I could do 3 of them. I wouldn't do 4 of them because remember we stop at the 180. So once you've made it to the halfway point, you shouldn't have to list anymore. So I think it's just those 3 clockwise that I have to list and their corresponding counterclockwise, and I should have hit all 7 points. And that's how we would describe the rotational symmetry of really anything that has sort of 7 points on it. You could imagine maybe a flower that looks like that or something. This next shape, it looks like I could rotate that top point to match up with here, and with here, and with here. So I think we've got one of those 4 pointed things again. If instead you wanted to look at these smaller ones, we would still have 4 because that would rotate to here, and that would rotate to here, and that would rotate to here. So either way, you're going to have sort of 4 clicks, 4 rotations as you turn that around. 360 divided by 4 is 90 degrees, so we'd have that 90 degrees clockwise and counterclockwise. And then to get down to that bottom point, we would have to do a 180. Let's take a look at this Yankees logo. How far do I have to turn it before it looks like itself again? Well, by 180 degrees, once I have it turned upside down, that N still looks like an N, but the Y doesn't work, right? So how far would I have to turn it before it looks the same? I would have to turn it all the way around. So 360 degrees doesn't actually count as a rotational symmetry because anything has 360 degree rotational symmetry. So in this case, we would say, does the figure have rotational symmetry? That would be a no. Now had that Y been maybe an X instead, an X looks the same upside down, right? So if it was NX, then I could have said that it had a 180 degree symmetry. So that's our lesson for today. We learned about line symmetry, which is more like a reflection or a fold, and rotational symmetry.